In this example, we're going to graph the rational equation. We're going to use vertical and horizontal asymptotes, if they exist, and then the x and y intercepts. Sometimes we might need to plot some other points just to get a better shape of the graph. So let's talk about the vertical asymptotes and then any holes that might exist for this rational equation. What we want to do is we want to try to factor the numerator and denominator. So if I find a GCF here that's going to be 2, then I'll have 3x minus 2, and then in the denominator I can factor a negative 3 out, and I'll have x minus 2. When we do that, we're going to take a look in the top and the bottom and see if we have exactly the same factor. If we do, that's a hole. If not, it's a vertical asymptote. You'll note that this is 3x minus 2 and this is x minus 2. They're not the same. So there's going to be a vertical asymptote wherever x minus 2 is equal to 0. So we'll add 2 there, and we've got a vertical asymptote at 2. To find the horizontal asymptotes, or asymptote, what you're going to do is you're going to take a look at the numerator and denominator. You want to look for the highest power of x that you see. In this case, we have a 6x here and a negative 3x, so the highest power is 1. What we're going to do is we're going to take these terms and we're going to look at their coefficients. If for some reason this was x squared, you would add a filler, and this would be 0x squared plus 6x minus 4, and then you just have 0 over negative 3. But in this case, we kind of get lucky here. We have a 6x and a negative 3x. When you do this, you need to make sure that that x is being raised to the same power and that it's the highest one that you see in the example. So we're just going to take a look at the leading terms here, 6x over negative 3x. The x's will cancel, and 6 divided by negative 3 is negative 2. This is a horizontal asymptote, so the actual equation of the horizontal asymptote is y is equal to negative 2. We're also asked to find the x and y intercepts. I'm going to move this up a little bit as we're going to need to graph it here shortly. We might need a little extra room here at the bottom as well. So to find the x-intercepts, that's just where the value of y, or f of x, is 0. And note that if we want 0, then just the numerator of the fraction needs to be 0. This bottom can be anything. As long as 6x minus 4 is 0, 0 divided by some number will give us that x-intercept, or that 0 for f of x. So what we need to do is just set the numerator here equal to 0 and solve. So we'll divide by 6 here, and we have an x-intercept then of negative 2/3, comma 0. Alright, we'll do the y-intercept. This one's pretty easy. X is going to be 0 here, so any term with an x in it is just going to be gone. X is 0 for the y-intercepts, and so we have negative 4 over 6, so we've got negative 4 over 6 there. And we find that the y-intercept then would be 0, comma negative 2/3. Alright, now we found the vertical asymptote, horizontal asymptote, x and y intercepts. We're going to see if that gives us enough information to plot this thing here. So let's go ahead and draw the asymptotes. The asymptotes, by the way, are not part of the graph. I like to think of them as helper lines. They just help us to draw the graph. And so our vertical asymptote is at x is equal to 2. And I'll just draw this dashed as we go here. You can do it lightly if that's your that's the way you like to do it, your style, or you can do like a dashed line here. Alright, the horizontal asymptote is at y is equal to negative 2. So that'll be this right here. Alrighty. And those would be our guidelines, kind of. We can, in this case, plot the x and y intercept. So the x-intercept is negative 2/3 right here, 0, and the y-intercept is also going to be negative 2/3. And so that will be down here. And I may have made a mistake here. We'll see what happens when we graph this thing, but that should be right there, I think. Alright, and what we'll do then is we'll take a look at the graph of this thing. And we can see here that the graph, and I'm looking at this first one right now, that's the first graph that appears here, is that this graph is going to look curved, and it's going to kind of look curved like this. So I'm thinking I made maybe a slight error here in finding the x-intercept. I hope I didn't do that, but it's quite possible. So let's see, we had the numerator equal to 0, that's fine. And we ooh, there it is right there. Did you catch it? Oh shoot, I subtracted when I should have added. So this should just be a positive 2/3 there. So please disregard this negative 2/3, and we're going to make it a positive 2/3. And now we have something that looks a little bit better. Notice how if you go to the intersection of the, let's see, this vertical asymptote here and this horizontal asymptote, that intersection, if we go up to the left 1 1/3, that point exists. And this point, this graph is going to have some symmetry here, so we could also go down to and right 1 1/3. We could also go left 2 and then up 1 1/3, and we could go right 2 and down 1 1/3, and we'll get kind of that mirror image of these points across this this point right here. So that'll help us to draw the curve of the line here. Okay? So there you have it. We're just going to get close to those asymptotes right there. And this is actually not a point, so please don't plot that. I'm sorry if you did already. Hopefully you're able to write in pencil and can erase that thing there. And so this is the actual shape of the graph. We've used our calculator to help us and found all the pertinent information right here.